there, and welcome to another tutorial. My name is Tanmay Bakshi, and this time we're going to be going over how you can use PyTorch and specifically OpenNMT-py in order to run neural machine translation tasks. Now, essentially, what I'm going to show you today is how you can use a sequence-to-sequence LSTM, long short-term memory network, in order to convert from English to French sentences. In fact, today we've also got a special guest on the show who is proficient at French and will be helping us out with testing out the entire system. We'll be getting to that in just a little bit, but just before we get to that though, I have to tell you that if you've watched my auto-encoder video before, that will really help you out in understanding how the system actually works. There will be a link down in the description to that video, and that will give you a good base to start off of. But for now though, let's start with this video. Now first of all, how will this system work? Well, if you've watched the auto-encoder video, you know that neural networks can take information, really condense that information down into just a few points, a few numbers into a small vector, and then decode it and really expand it back up to its original form, or at least really, really close to its original form. Now, neural networks are great at that, but what if you could take information, decode it down into a really small vector, then or encode it down into a really small vector, and then decode it into another really big vector that has a slightly different way of representing the same information. For example, if you were using a regular MNIST autoencoder, which I talked about in the last video, you could have a neural network that took in a regular MNIST digit and outputted an inverted color version of that image. It would be representing the same information in a different way. What if you could apply the exact same technique to language? That's right, so now I'm going to show you how you can take English words, an entire English sentence, feed it into a neural network, have it condense that down, encode it into a small vector, and then decode it into a bigger vector. But this time, instead of representing the input as English word vectors, it'll represent them as French word vectors in the right order and the right grammar. This is really, really interesting, and there's actually an entire new approach. This is, in fact, an entire new approach to the machine translation problem. Instead of converting from words to words, which oftentimes makes mistakes, because of course in languages you don't always have the same word order. I want to order an extra large pizza in English could have an entirely different word order in French. However, with the neural machine translation system, it will learn how to change the word order, and it will learn which words to use in other words places, depending on the context as well, and the data that it was trained on. So now, let's get into an explanation of how the entire system works. Now, the neural machine translation bit has already been implemented on GitHub, and there will be a link to that GitHub repository down in the description below, and I'll be showing you that GitHub repository in just a moment as well. The original implementation for this was in regular Torch, powered by Lua, but now it's also been translated into Python due to PyTorch and its release. So now I'm going to show you how you can actually implement a neural machine translation system. But just before we get to that, I'd like to explain how the entire system works. Let's get started. Now let's take a really simple example sentence. Like for example, you say I want an extra large pizza, all right? Now you have this English sentence. I want an extra large pizza, and let's just say the person's name that you're asking, his name is James, okay? And so, now what you're going to do is, of course, this is completely valid in English, but let's just say you wanted to convert this to French. Now what you could do, which is the naive way of doing this, is you could just convert every single individual word to their French counterpart, which wouldn't be very nice. Of course, in this case, if you were to do that, that would be very, very grammatically incorrect, and no one would be able to understand that. However, there are some smarter ways of doing it. For example, the older method of Google Translate, which tries to do a little bit of a smarter machine translation, but I won't be getting into that algorithm just yet. However, with neural networks, all you have to do is take this sentence, send it to a tokenizer, okay? Okay, so now you're going to tokenize this. What that means is you're going to split every individual part of the sentence into, of course, as I mentioned, individual parts. So for example, you put a space before the comma, space before the punctuation, and what that would allow you to do is have a sentence that is completely tokenized, so the neural network can convert every individual tokenized element of the sentence into individual vectors that can go into the neural network at the end. After that, though, once the network, or once you have tokenized your sentence, you can vectorize the sentence. And what the vectorization does, of course, allows the neural network to understand the input. Now the vectorization, of course, you can do this via word vectors, really however else you'd want to. In this case, we're going to use glove word vectors, which I will also be talking about in the rest of the video. But once you have finally vectorized it, you can use a recurrent neural network to understand that vectorization, or that vectorized version of the sentence. And so in this case, you could just use any recurrent neural network, but I'm going to be using LSTMs. You could also use gated recurrent units, GRUs, but I'm not going to be sacrificing really any accuracy whatsoever. We're going to be going for LSTMs. Now the RNN, what it's going to do is it's going to take the entire set of huge vectors and convert it to one individual set of smaller vectors, a really, really tiny vector compared to what the input is. And that actually describes the entire input sequence in just one small vector. It describes all the semantics of the input without being very specific on what the actual words themselves were. However, there are a few problems with this. Like, for example, James isn't an English word. That's just some random word we came up with, in this case a person's name. So how do we deal with that? Well, what happens is the vectorization process, you could just input all zeros as a vector, you could input a random vector, but in this case what I'm going to do is input an all zero vector. And what that'll do is tell the recurrent neural network that this is an out of vocabulary word, it is an unknown word that it's never seen before, and in theory, the neural network should be able to replace this with a token. In this case, angular bracket UNK angular bracket. And then at the very end, once you are done converting it, you can put, you can actually replace all of the unknown vectors with the actual words from English, because of course it doesn't know how to convert them to French in the first place. But then again, once you're done with that recurrent neural network, it'll feed into one more recurrent neural network that will then take the encoded vector and then decode it back into a huge vector that represents this exact sentence in French, and then in theory, you should be able to reverse the vectorization process, and then you can do, you can basically take the vectors, word vectors to words, run this process in reverse, and then you should finally have your output, which is your French sentence, which is what I'm going to be showing you how to build right now. But now though, before I tell you how you can actually implement this system, I think it would be really interesting to see a demo of this in action. In fact, this is actually the exact system that Google Translate now uses for many different languages, as it creates much, much more accurate results. But now, let's get over to a demo of the system itself, where I'll show you a demo of around 7 different sentences and how they are converted to French via this entire system. So now let's get over to how you can implement this with PyTorch. Alright, so welcome back to the demonstration. Now I'm going to show you how the system actually works. Now, before we can actually take a look at the system, we have to find a way to see if the system actually works. And while I don't know French, there is someone who's joining me today, special guest, Abby, who is actually very proficient in French. Would you like to introduce yourself?
Hi, my name is Abby. I'll be helping Tadme with the French translation. Let's get into the video.
Perfect. All right, let's start. Now, you can actually see on screen right now, we've got 8 different sentences. And so these are straight from the French translation system, not been modified whatsoever. These are tokenized versions, so before punctuation, like apostrophes, commas, question marks, you've got little spaces here. However, those can be, untokenized just as easily. But for now, let's actually begin and see if the translation system works with a few examples. So now, Abby, what do you think the first sentence here actually says in English? So this is the French version. If you want, you can actually say out the French version, then we'll talk about the English.
Est-ce que vous allez à la manifestation xénophobie samedi, Emma?
Okay, so what do you think that means in English?
Okay, so are you going to the xenophobia protests Saturday, Emma.
Yes, that is in fact what it means. If we were to go to the English version over here, you can take a look, and the original English is, are you going to the xenophobia protest on Saturday, Emma? So yes, that is correct, and apparently the translation system has worked in this case. So that was a demo of the translation system converting one simple English sentence to French. Now let's try out a few more. So let's just try out number 2 now. So what do you think this is from French to English?
So la plupart des enfants de ma classe vont. All right.
Okay, so what would this be in English?
So, like, most of the kids in my class are going.
Yes, exactly. That is, in fact, exactly what it is in English. Most of the kids in my class are going. Now, let's try out one more. So, what does this say? So, this is French, first of all.
Okay. So, le plus grand jeu de hockey de la ville est ce samedi à 10h. Étiez-vous?
Okay, so what would that be in English?
So, like the biggest or largest hockey game, hockey game in the town is this Saturday at 10 p.m.
Okay, great.
Are you?
Okay, so does it, okay, so the actual sentence from English is, the town's largest hockey game is this Saturday at 10 a.m. Are you going? So does it mostly match up, or?
Yes, it mostly matches up. But here at the end, where it says "êtes-vous," it just says, like, are you? There's no other verb. It's not asking, like, are you going, or anything like that.
Yes. So in this case, the reason for that would be that the perplexity of this model is actually 6.07, which is relatively high, and this was only trained for around 24 hours on a, mid-sized GPU. So if we were to scale that up to more GPUs and much more training time, then we should get a much lower perplexity, in this case basically meaning error rate, and we should be good to go, and it should be able to translate that nicely. And plus, this is trained on much more formal sentences, not in this context. However, it is, again, completely possible to fix that error with more training data and more training time as well. Let's try out number 4 now. So this is French, first of all.
Okay, so les billets seront à la vente à partir de 10h sur jeudi.
Okay.
Okay. So it says that the tickets are going on sale at 12 o'clock Thursday.
Okay, so was there an error in this sentence?
Yes, it didn't translate to Thursday.
Okay.
It just left it as Thursday.
Okay, so again, that is because we're using very little training data, meaning that Thursday is not in the vocabulary. This is, again, an issue with the training data that we have. If I were to have more training data, for example, from some corpuses that I'm going to be showing you at the end of this video, we'd be able to get much higher accuracy. But then again, I'll get into that in the second part of this video. For now, let's just continue with simple sentences. Number 5 now.
So also for the sentence number 4, the one about Thursday, it shouldn't say sur. It should just say Thursday, because like you're saying it's like on Thursday. There's my French teacher said that it sounds weird because you're saying that it's like on top of like Thursday, so you just say Thursday.
Oh, okay. So again, this is one of the examples where less perplexity, it should understand that grammar and should be able to understand that on in some contexts means, without sir, some without, so with sir. In this case, since it didn't understand Thursday, that wasn't in its vocabulary, it didn't understand Thursday, and it thought it might literally be on top of something. And so it wasn't able to infer from that context. But if that were in the vocabulary, it would understand from the context and not insert sir. So next, number 5. So this is French, first of all.
So, le français est une langue très importante pour étudier. À tant de pays dans le monde parlant cette langue.
All right, so what do you think that would mean in English?
So, French is a very important language to study. Other countries in the world speak this language.
Okay, sure. So now that's actually very close to what it was. French is a very important language to study, as many countries around the world speak this language, is exactly what the English version was. However, it seems as if as many may have been left out by the translation system, was it?
So we learned, since we're in Canada, we learned Quebec French, and this is translating French. So some of these words may be different from what we may say in Canada versus what we may say in France.
Yes. So that might be one of the reasons that it's a little bit more confusing. However, let's go over to number 6, which is actually relevant. So number 6, this is the French version of the sentence. What do you think it would mean in English?
Okay, so par exemple, il s'agit de la deuxième langue officielle du Canada.
So what would that mean in English?
Okay, so for example, it's a second, it's the official second language of Canada.
Perfect. That is exactly what it is in English. For example, it is the official second language of Canada. Now let's try just 2 more and see how exactly we're able to use the system. So now this is, of course, prediction number 7. Let's talk about this one.
So, décrivez une personne dans cette classe et vos camarades de classe devront deviner qui il est.
Okay, so what do you think this would mean in English?
Okay, so describe a person in this class, and your classmates or other students in the class will have to guess who it is.
Exactly. Again, semantically the exact same as what was entered into the system. Describe a person in this class and your classmates will have to guess who it is. Now, one more thing I'd like to point out here is that if I were to take the original English sentence here, and if I were to copy that back into this document, take a look at these 2. Is it copying the punctuation like correctly where it should be, like the commas, and of course the end is correct, but is the comma at the correct place where it should be? Is all the punctuation taken care of nicely?
Yes, the punctuation is taken care of.
Perfect, that's great. So system, again, is learning exactly how to use that punctuation as well, contextually with the rest of the sentence, even though it's scaling all of that information down to a really small vector. However, let's try out one more over here. Prediction number 8.
Okay, so le gagnant recevra un prix. Okay. So the winner will receive a prize.
Okay, again, exactly what it was in English. This one was actually completely correct. The winner will receive a prize, exclamation mark. And so that was a demo of the system in action. So how would you rate the system?
I would rate it like an 8.
8 out of 10?
8 out of 10.
Perfect.
There were just like some errors where it wouldn't pick up on some words.
Yeah.
And also it would bring like the English word into, like, it wouldn't translate the English word.
Exactly. It wouldn't translate the English word individually to the French word. Again, all solved with more vocabulary, more training data, higher vocabulary size, and of course, more training time as well. However, just for 24 hours of training, this is a relatively good system, and OpenNMT-py allows me to build this really, really easily. So now I'm going to be getting over to the actual coding part, where I'm going to show you how to implement this entire system, how to get all the training data, and then how to calculate a BLEU score to find out how good your translation system actually is. Now let's get over to the coding part. Thank you, Abby.
You're welcome.
Alright, so welcome back to the coding part, and now just before I begin, I would like to say a big thank you to the guys at Harvard for actually making this so easy. Now, if you actually take a look, OpenNMT itself as a project was actually created by the folks over at Harvard, which is simply amazing. Makes it so easy to train neural machine translation systems with both Torch and PyTorch, which surprisingly, of course, I mean, of course, it works with PyTorch due to the fact that it does work with Torch, PyTorch being a port of Torch to the Python world. Of course, really popular, relatively new as well, and it's an amazing library, which I'll be getting a lot deeper into in future tutorials, because again, instead of relearning a language like Lua, you can just use these sorts of Torch library in the Python language. However, now though, I'm going to be bringing you into actually how you can use OpenNMT on some simple data. And by simple though, I mean French to English and English to French data. In this case, I'll show you just the English to French version, and then I'll talk about why it's so interesting. Now let's start off with the code itself. How do you train the system? It's really easy. In fact, I just created one simple shell file that automatically trains it for me. First thing it does, of course, is in the shell file, it gets some tools that'll help it to tokenize and find the blue score, etc. In this case, though, these tools, I'm only using the tokenizer for now, and a few of the other tools. The blue score is something that will come in a separate part of this series. But after that, once we've gotten the tools that'll actually help us pre-process our data, we've got to pre-process the data itself.
Now, in order to pre-process data, we've got some really simple commands that run these Perl scripts that I actually just downloaded. And so, as you can see, or in fact, we actually wouldn't necessarily need these 2 lines of code here, so we can remove those. Those aren't actually being used in this circumstance, although for other German to English ones, they will be used, but we don't need those tools in this case, so I'm only going to be downloading these tools here. But after that, of course, as I mentioned, getting back to the point, we've got to pre-process our data. Now, in order to pre-process data, we've got a really simple script that's running here. First of all, it tries to actually remove the very first and last lines from the files themselves, just in case there's extra space. And then finally, you're going to tokenize all the training data and testing data to make sure that the model actually understands the data. From there, though, we've got a Python that actually really pre-processes all the data and takes all of these, tokenated files and actually converts them to data that the neural machine translation system can understand and work with in terms of training. After that, though, the actual training of the model comes in, and it's as simple as 1 line of code. That's right, a simple Python 3.5 called the train.py, pass it the data, tell it where to save the model, in this case, multi-30K model, and finally, give it your GPU ID. In this case, I'm only using 1 GPU, so GPU 0. That's right, it's that simple to train the system. However, you've got to have your data. Now, in this case, if you go over to my data/multi30k folder, you can see that I've got quite a few different files here. And if you were to remove the pre-processed versions of these files, you can see that I've got train.de, train.en, and val.de and val.en. Now, the train files are what's going to train the system, and the val files are what's going to validate the system to find out what types of accuracy we're getting. Now, in this case, I'm using English and French. However, it is annotated as DE and EN. You can ignore that for now. That's just to make it compatible in general. Like, for example, target is DE, and where you're coming from is EN. So you can actually paste in any information that you want to within these 2 files and learn eventually using sequence to sequence how to convert from one language to another. In fact, you can apply this to really anything. Like, for example, IBM Watson has a text-to-speech service, and what it allows you to do is to say, like, for example, instead of just giving it text and hoping that it says it correctly, you can actually give it certain expression on the text. So what you could do is you could build one of these sequence-to-sequence systems to actually automatically convert just regular text to text with expression to tell Watson exactly what expression. So Watson does the main text-to-speech for you, but you do the expression handling for the voice itself, just in case that you want a more personalized or accurate version of that expression handling. And so there are all sorts of things that you could possibly do with this. But for now, all you really need to do is actually go back to this directory, run bash train.sh, and that's all you need to do. Now, it's only going to work with bash because of a few specific commands that this shell file has, but try that out. As you can see, wget's going to do some really interesting stuff. It's going to start gathering some of the tools, and at this point, it's pre-processing the data. Once it's done pre-processing the data, it's going to actually start training the model through the train.py file. Now, instead of me actually showing you this model training, which would, I assume, be really, really repetitive and it would take a long time, instead of me showing you how the model is trained, let's just skip over to the evaluation of the model itself. So now remember, I have already trained this model, and now we're ready to actually take a look at how it performs. You already saw some simple classifications and translations, or not classifications, just translations that I did before with Abby's help, but now I'd like to show you how exactly you run those translations in the first place. So let's just Control-C this script over here, and let's go over to the folder that contains my pre-trained model. And then what I'll do is I'll get out this command. And this command will allow me to actually translate from English to French. How does it do this? Well, if you take a look over here, I've defined a specific model for the program to use. Now, every epoch, it will actually log down, or it'll checkpoint a model. It tells you the accuracy count, and it gives you the perplexity as well. In this case, I reached a perplexity of 6.07 at the 13th epoch. Which is, it's okay. It's not the best you could get it. Of course, you can get it much, much better than that. However, 6 is relatively low. Of course, I would not use the translation system until it's less than, say, like 8, or at least in the single digits is minimum to actually start using it. 6 is still a little bit high. If I were to use this in my everyday life, I want to train this even more. However, apart from that, though, again, you're going to tell it which GPU to use to translate. You can also do this with CPU, but GPU is better. Of course, apart from that, we're going to tell it where to translate from, in this case, a text file. And, of course, we're going to tell it to replace unknowns. And what that means is that, if, for example, if there's an unknown input in the original text file that you're converting from, try and find out using attention mechanisms where that would be in the output and replace that in the output so you have final translations, and do it in a verbose way so we don't need to save the output to a file, we can just see it in the terminal. Before I run that command, though, I'd like to actually create the command, the sentence for us to translate. So let's just open up a new file here called, say, yttranslate.txt. Now, what I'm going to say here is I am recording a video for YouTube, and I hope this translation system works. I don't have someone to translate for me right now, so I won't be sure. All right. So there we go. Now we've got 2 sentences. Now in theory, again, I've manually tokenized this. For example, before and after the apostrophe, there have to be spaces. Same thing with the period at the end and the commas in the middle. And so as you can see, once you've got this all tokenized and nice, I'm going to save the file. I'm going to run the same script, Python 3.5, or we could just copy and paste this command here. And what I will do is pass it the YouTube translate.txt file. We're going to use the same model, and let's hope for the best. Now again, unfortunately, I don't have Abby right now. However, what happens is, we've got this translation ready. As you can see right now, this is where the perplexity comes in. It has not been able to translate this sentence here. Why? Not sure. But how can you fix it? Well, by using much more data than I currently am, because I'm using a very, very small data set. And you have to train it for much, much more than 24 hours, even if you have a much stronger GPU. With, for example, the GTX 1070, this would not be nearly fast enough to be finished in 24 hours. So again, more epochs, better model, better data, and you will get much, much higher accuracy. However, I do actually hope that this very first translation here was correct. In fact, if anyone here in the comments knows French, I'd love to hear from you and see if this translation was correct. Alright, so that's what we have to cover in terms of the actual implementation. That's right, it's that simple to train and test a neural machine translation system through OpenNMT-py. In fact, in later tutorials, I'll be showing you how to actually build this type of system from scratch in Keras that actually takes in its own input data, own output data, and does everything manually. But for now, I thought it would be more interesting to actually take a look at the concept itself and an implementation by the folks at Harvard. Next, though, let's talk about the errors that the model made last time while I was with Abby. Now, the first one you may have realized here was the xenophobia one. Now, of course, it says, are you going to the xenophobia protest on Sunday, Emma? Now, you may have noticed that it did not translate xenophobia to its French counterpart here. Why didn't it do that? Because xenophobia was misspelt. In fact, if you see over here, I've actually correctly spelled xenophobia over here in Are You Going to the Xenophobia Protest on Saturday, Emma? And what happened is the model actually changed the grammar. Not only did it translate xenophobia to xenophobie in the French sentence, it changed the beginning grammar of the sentence itself. Look at this. We've got "Étiez-vous au rendez-vous de là" over here. Again, sorry not pronouncing that correctly, but we've got something entirely different over here. So remember, even that small of a change, the fact that it did not understand xenophobia, made it that it had to infer that it's referring to xenophobia in a different context. When it understood xenophobia and was able to translate it correctly, then it understood that context and was able to create the correct, grammar before xenophobia. But an even more interesting example, though, which really proves the context dependence, is this one. Now, as you can see, there's an error here. Tickets will be for sale at 12 p.m. on Thursday. Now, Thursday is not a word in the vocabulary, but Thursday itself is. Thursday ! Isn't a word in the vocabulary itself. That means that the sentence wasn't tokenized correctly, which is why it did not translate Thursday to whatever its French counterpart is correctly, and it didn't use correct grammar in the rest of the sentence. However, what's really interesting is once I tokenized it correctly over here and fed it back into the model, as you can see, again, almost entirely different grammar. It's not literally putting 12 hours on Thursday. Instead, what it's doing is it's saying 12 on Thursday. It is contextually very correct, which, as Abby was pointing out, makes it sound as if something is literally on top of something, and because the fact that the model never knew that Thursday wasn't referring to a day, it thought that was an object or something of that sort, and it thought it was literally on it, and it used sur. So as you can see, it is very, very context dependent. However, once it gets the context that it needs, it makes extremely accurate, human-like, natural translations that sound good to the people who actually know the language and don't seem awkward or weird in terms of word order or grammatic choice. Like, for example, if you have an English sentence, like, for example, you have an English sentence, like, for example, I'd want a large pizza. You wouldn't want to form that in French in a formal way. And so that's why the Watson language translation service allows you to actually choose the context in which your language translation should be done. And so depending on the data that you train the neural network with, you can actually choose the context or the formality in which this conversation is taking place. And so, for example, if I'm at a pizza place, I might not want to sound really formal with my French, like I'd like a large pizza, please. I mean, you don't want to sound really formal. However, if you're speaking to, for example, you're making an automatic translation system for the UN. In fact, there's actually a data set from the UN, their speeches, English to French, French to English, and lots of other languages as well, which is something that I'm going to be working on in another part of this video. And that actually highlights really, really formal French. And so depending on what you train the model on, that's the knowledge it'll gain, and that's the type of language it'll convert to and from. And so again, that's why these models are so great. You can personalize them to specific contexts, you can personalize them to specific occasions or where you'd like to use them, and that was what I had to go over in this video. Thank you very much for joining, everyone. I really enjoyed making this video. I hope you enjoyed watching and you learned something along the way. Thank you very much for joining in today. That's going to be all for this video. Of course, if you like the video and you want to see more of it, please do consider liking the video, sharing it with your friends or family, or whoever else you think may benefit from it. And of course, from there, if you have any more questions or suggestions or even feedback, please leave it down in the comment section below. Email it to me at tadgymani@gmail.com or tweet it to me at tadgymani. Apart from that, thank you very much, everyone, for joining in today. If you really like my content and you want to see more of it, please do consider subscribing to my YouTube channel, as it really does help out a lot. And thank you very much, everyone, for joining. That's going to be all. Of course, do turn on notifications if you'd like to be notified of whenever I release new content. Thank you very much. Goodbye.